Hi, welcome back to Moose and Chemistry. This is Thermochemistry, Gibbs free energy, and Enthalpy and Entropy lesson number 3. Okay, given the following formula, this is a Gibbs free energy formula, delta G equals delta H minus T delta S. Is this reaction spontaneous? Okay, well, let's look at it. So we have our players delta H, delta S, and delta T right here. So let's go ahead and plug in and see what we get. So we get delta G equals delta H, which is minus 232 kilojoules, minus 273 K, minus 0.138 kilojoules over K. So delta G now equals minus 232 kilojoules plus 37.67 kilojoules, and we add the two together. Delta G is negative 194.3 kilojoules. All right, so let's see here. When delta H is negative and delta S is negative, it's spontaneous at low temperatures. And so we have a definitely low temperature there. So this is spontaneous. Pretty cool, huh? All right, so let's look at the next problem. The next problem is CO plus S plus oxygen yields, looks like cobalt sulfate, with our delta HF equals negative 888.3 kilojoules per mole, and our delta SF equals negative 118.0 kilojoules per mole. Delta G is equal to 0, so remember that F degree stands for formation. At what temperature will this reaction be spontaneous? Okay, well, let's go ahead and write our formula. Delta G equals delta H minus T delta S. Okay? So delta G is 0. Delta H is negative 888.3 kilojoules per mole. Minus negative 118.0 kilojoules per mole. Okay. And we're going to put I'm going to put times T on this side right here. Just going to move it around a little bit. So T is going to equal, let's see here. So bring the 88 over, 888.3 kilojoules per mole equals a negative is a positive, so that would give us 118.0 kilojoules per mole times T. Right? So T is going to give us our temperature, which is in Kelvin, 7.53 Kelvin. And that's it for this lesson. So at this temperature, this reaction would be spontaneous, which is pretty darn cold because considered 0 Kelvin is absolute 0. So 7.53 is not much higher than 0 Kelvin. Will you guys be snarly And we'll see you back here at Mucine Chemistry.